This video will cover the topic, multiplication involving binomials and trinomials in one variable. This topic relies heavily on distribution, where we will multiply each term of one polynomial by each term of the other polynomial. Let's dive right in and look at an example. Here we have the quantity 6y plus 2 times the quantity 3y squared plus y minus 4. We will need to distribute by multiplying every term in the second polynomial by the 6y and by the 2 in the first polynomial. We will start by multiplying 6y times 3y squared, which results in 18y cubed. Next, we multiply 6y times y, which results in 6y squared, and we multiply 6y times negative 4, which results in negative 24y. Next, we multiply 2 by 3y squared, which results in 6y squared. Now we multiply 2 times y, which equals 2y. And lastly, we multiply 2 times negative 4, which results in negative 8.
I see that there are like terms that I can simplify, but everything's so jumbled up, it's hard to keep track. Is there a better way to organize this?
You're right, there are a lot of terms here. Why don't we rearrange things so we can add the like terms vertically? We have one term with y cubed in it, so we'll start by leaving that one where it is. Next, we have two terms with y squared, so we can put the purple 6y squared beneath the blue 6y squared. We also have two y terms, so we can put the purple 2y beneath the blue negative 24y. Lastly, we have one constant term, the negative 8, so we can put that one next to the other purple terms. Now that we have our like terms arranged vertically, we want to add the vertical columns.
But what do we add to the 18y cubed and the negative 8?
That's a good question. On the top row, we don't have a constant term, so that's like adding 0. In the bottom row, we don't have a y cubed term, so that's like adding 0y cubed. Now we can add 18y cubed plus 0y cubed to get a sum of 18y cubed. Next, 6y squared plus 6y squared equals 12y squared. Negative 24y plus 2y is negative 22y. And 0 minus 8 equals negative 8. This tells us that when we multiply the binomial 6y plus 2 times the trinomial 3y squared plus y minus 4, the resulting polynomial is 18y cubed plus 12y squared minus 22y minus 8.
Wow, that makes everything much more organized. Can we try another example?
Let's take a look at the quantity 2v minus 7 times the quantity 3v squared minus 6v plus 1. How do you think we should start?
Well, we can first multiply 2v times 3v squared to result in 6v cubed. Then 2v times negative 6v is negative 12v squared. And 2v times 1 is 2v. Next, negative 7 times 3v squared is negative 21v squared. Negative 7 times negative 6v is 42v. And negative 7 times 1 is negative 7. Now, we can add the vertical columns. Since the bottom polynomial doesn't have a v cubed term, 6v cubed plus 0v cubed is 6v cubed. Then, negative 12v squared minus 21v squared equals negative 33v squared. And 2v plus 42v equals 44v. Also, since the top polynomial doesn't have a constant term, 0 minus 7 is negative 7. So this is our final answer, right?
That's right. After multiplying the original polynomials and simplifying, our final answer is 6v cubed minus 33v squared plus 44v minus 7.
Okay, so when multiplying binomials and trinomials together, we distribute each term of one polynomial to each term of the other polynomial, and we can organize the like terms into columns in order to add and simplify.
Great job! It sounds like you've got the hang of this topic.